Time doesn't tick at the same pace everywhere in the universe. The closer you are to a massive object, like a planet or a star, the slower time moves for you compared to someone farther away. This isn't just a strange idea, it's a real effect predicted by Einstein's theory of general relativity. Imagine standing on the surface of a giant planet, feeling its immense gravity. Every second for you would be just a little bit longer than a second for someone far out in space, away from the planet's pull. Now take this to the extreme. Near a black hole, where gravity is unimaginably strong, time slows down so much that it almost comes to a halt. If you could watch a clock near a black hole, its hands would barely move, while clocks far away would spin on as usual. This might sound like science fiction, but it's a phenomenon that scientists have measured and confirmed. Using incredibly precise atomic clocks, researchers have observed time moving at different rates depending on altitude and gravity, even on Earth. In fact, the satellites that power our GPS systems have to account for time dilation. Their clocks tick slightly faster than those on the ground, and engineers must correct for this difference so your phone can tell you exactly where you are. Why does this happen? Gravity doesn't just pull on objects. It bends the very fabric of space and time, creating curves and warps in the universe. And time itself follows those curves, flowing differently depending on the strength of gravity in each place. So, when you fall into a gravity well, toward a planet, a star, or even a black hole, you're not just falling through space. You're also moving through a landscape where time itself is stretched and warped. In a very real sense, you are falling into time itself, experiencing the universe in a way that's both mind-bending and beautifully strange.